Welcome to Linux Saints YouTube channel. In this video, we are going to be focusing on the implementation of linked list in the C programming language. In the previous two parts, we have already discussed what a linked list is, how is it different from arrays, and how to create nodes in a linear linked list. In this video, we are not just only implementing the linked list, we are also going to perform operations like sorting, searching, and traversing. So as you can see, I have already included the set of libraries that I need to make this implementation work. And then I've also created a self-referential structure named as node with members like data, key, and the next node. And I've also declared some members globally, which is the head pointer and the current pointer. Now from the previous video, you should have an idea of what these nodes do. So let's write the first function, which is to print the list. So what we are doing over here is that we are creating a variable pointer and setting it equal to the very first node, which is placed inside our head pointer. And then we are simply saying that while my pointer is not null, keep printing out the pairs, which is the data and the key values. And after printing out every pair, head inside that structure, which is the node structure, and change my pointer value to the value which is placed inside the next variable, which would give us the reference to the next element or the next node in the linked list. So that's how we are going to traverse through the whole list and print it to the terminal. And then we are going to create a function that is going to insert the very first node inside our linked list. So this function would have two arguments, which would be the key and the data value. Now we have already explained how to create a node in the linked list in the previous video, so you should have a very clear idea about what this is. So what are we doing over here? So basically we are creating a new node, and then in this node we are passing in the values that have been passed in this function through its arguments. And then since we have already said that this would be the very first node in our linked list, so we change the value placed inside the head pointer to the value of this particular node, which I have named link. After that, we are going to write a function to delete that very first node. Here as you can see, I have created a function called delete first, which would help me delete the very first node in this linked list. So to delete any node from a linked list, we simply need to get rid of its reference. So what we did was, we went inside the head value, which contains the link of the very first node, and we shifted it to a temporary link variable. And then we changed the value of that head pointer to the next node in the list. For example, if you have 3 nodes, 1, 2 and 3, and you want to remove the first node, the head pointer is pointing to the first node at the very start. And if you remove that first node, the head pointer now should point at the second node. So that is what we are doing over here. And then we just simply return the temporary link. And then we also want a function that would help us check whether the linked list is empty or not. Well, for that I'm just simply going to create a boolean function, name it as isEmpty, and then within this function we simply have to do one thing. If our head pointer is null, then that means we have no node inside our linked list. So that's how you check for an empty linked list. And then if we want a function that would return us the length of the whole linked list, as you can see, I've created a function of the return type integer. So what I'm going to do inside this function is that I'm going to initialize a variable length and give it a value of 0. And then I'm going to create another variable of the node structure and call it the current pointer. And then I'm going to create a for loop with the condition that start from the beginning, which is the head pointer, and keep repeating the following sentences until the current pointer points at null. That means there is no more elements in the node. And for every iteration, change the current value to the value placed inside the link variable, or in this case, the next variable. And for every iteration, you have to increase the value of the length variable. And at the end of the function, return the length variable. And if you want to search for a particular key or for a particular node with a particular key from within the linked list, so we're going to write a function as find. So within this function, the first thing that we want to do is that we want to start from the very first node, which is in the head pointer. And then we want to check if the head is null. We want to say that, okay, there are no nodes, so we cannot find the ones you're looking for. After that, if the linked list is not empty, we want to go through the whole linked list. And by now we already know how to do that. That is to go inside the current node and then the key value. If the key value of the current node does not match our query or the key that we are trying to find, then the first thing that we want to check is that whether there is even a next node or not. And if there is no other nodes, then we will return null. Otherwise, we are going to change the value of the current pointer to the next node in the list. And if the value of the current key matches our query, then we are going to return the value of the current pointer. Now if you want to delete a particular node from the linked list depending upon its key, that is also pretty similar to finding the key value. But the only addition is that you have to remove the link of the current variable and bypass the link of the current variable as well. So we are going to write a function delete, and just like what we did in the search function or the find function, we are going to start with the very first node and we are going to set the value of the previous node to null. And then we are going to check whether the linked list is empty or not. And then we are going to do the same thing which we did in the find function. And if we found a match, we need to update the link by changing first node to point to the next link. Otherwise, we need to bypass the current link. So to bypass, we need to go in the previous node and change its next variable. And lastly, we are going to return the current variable. And then we are going to write a function to sort the linked list. So to sort the linked list, we are going to need the following integer variables I, j, k, and a temporary key and a variable to store temporary data. And then we do need the current pointer and the next pointer. So to start off, we want the length of the linked list. We've already defined a function to get that, so we're going to use that function to get the length. And then we are going to store that length in the k variable. And then we are going to traverse through the linked list using a nested for loop. And then we are going to compare the values of the current node's data to the next node's data. And if the current node data is greater than the next node's data, then we are going to swap those values. But since it's not just a simple array, we need to swap those keys as well. And then lastly, we need to change the value of the current node to the next node. And then we also need to change the value of the next node. And then we want to write a function to reverse our linked list. Now reversing a linked list is a little more complicated because we need to use a double pointer. Now what is a double pointer? Well, a pointer to a pointer variable is known as a double pointer. So to reverse a linked list, what we are going to do is that we are first going to set the previous value to null and then the current value to the pointer of head reference. And then we are also going to create a node for the next value. And we are going to say that while our current is not null, so swap the values of the previous node of the current node and the next node of the current node. And at the end, change the value of the head reference pointer to the previous reference pointer. So now inside our main function, let's try inserting some values. Let's give it some key value and some random integer values. And then we are going to print out the linked list by using the function that we created, which is the print list function. And then let's try to delete this whole list by using the delete first function multiple times, or I should say inside a while loop. So I'm going to say while my list is not empty, which is a function that we have created. So while the list does not become totally empty, we are getting the value delete first function, and then we are prompting the user that this is the value that we have deleted by getting the key and data values from the temporary variable that we have created inside this while loop. After deleting everything, the list looks like this, and then again call the print list function. Now we again need to put some values inside our linked list. Let's try to print our list one more time. Then let's try to find a particular value from our linked list. So we are going to use the function which we have created, which was the find function, and we are going to look for a node with the value or with the key 4. And then we are going to check whether the return value from that find function is empty or not, because if it is null, then that means that we were not able to find any value. But in case if it was non-null, then we were able to find our node with our particular key. So we are going to prompt the user that we have found the element, and we are going to display the key and the data of that element. And we are also going to type the else condition as the element was not found. And then we are going to try deleting the value from our linked list. So let's try deleting the node with the key 4, and then we are going to print the list one more time, and then again we are going to find 4, just to showcase that after deleting we were not able to find that element. And then let's try our sort function to sort out the linked list, and then we are going to print out the linked list after sorting it. And then what we are going to do is that we are going to reverse the linked list by passing in the head value, and after reversing the linked list we are finally going to print out the linked list for the last time. So that was all of the code needed to implement the linked list structure in our C programming language. So let's cross our fingers that we don't get any errors, and let's try executing this code. So okay, everything seems to be working. Let's go through the output. So we started out with this linked list and then we deleted out every item from this linked list. After deleting every item, the linked list was totally empty. Then we inputted some new values, which were these, and then we tried finding out the node with a key value of 4. And then what we did was we deleted the value with the key being 4. And just to confirm that we have deleted the node with the value 4, we tried the find method or the find function one more time. For the second last step, we tried sorting out the list according to the values, and then for the last step, we reversed that sorted linked list and printed it out to the terminal. So that was the implementation of a linear linked list in the C programming language, along with various operations like sorting, searching, deleting, and traversing.